Very good day. I'm going to do a short practical series where we start with a very simple model, perhaps a vertical or a dipole or something, and we'll build up through loops, coils, end feds, inverted Vs, phased arrays. Basically, I want to impart the knowledge I've got when it comes to software modeling antennas to someone like you. Each video is going to be under 5 minutes, no waffle, no maths. And if you work through all these kind of tutorials, you'll be as comfortable as I am. I suppose about, in all, it'd be about an hour's worth of watching. But, you know, you can dive in to which one you want. So we're going to use MMANA-GAL, right? It's free. It runs from a folder or, you know, a USB stick. It's portable. It's good enough to help you understand, you know, what actually happens when you change the height, the length, the geometry, particularly on the far field plot. Now, there's really expensive modeling tools out there and some free ones, but I've had a look at them and they look brilliant, but, you know, I just know what I know, all right? It's not about which software, it's about understanding behavior, particularly the far field pattern, angles and trends, without getting too lost in all the detail. So I'm just going to download it here, MMANA-GAL. It's normally the first click. There it is there. And you scroll down, not too far, and it says basic version, right? You don't want the pro version, you want the basic version if you're just playing, okay? Click that and it'll download. Now, I've already downloaded it, so I don't need to do that. But what we'll do is I'll just run it now, and we'll just quickly run through some odds and ends. We'll do a little Easter egg today, or we'll do maybe a dipole, something like that, just to show you. Right, on first run, it's probably not going to be English. It's probably going to be German, and it'll look like this, and that'll really confuse you. So you do setup Sprachen English. All right, let's move on. In the main, you've got these 4 tabs across the top, where my mouse is, top left. So we've got the geometry tab, I'll come to in a minute. This is where we can just look at it and go, yeah, that looks about right. This is where we run the calculations. And then this is where we'll see some pretty stuff, okay? Now, the geometry, it's important to note, do you remember at school, right? Rather than guessing your skill level, let me just start from scratch. So you'll remember at school we had you could do a graph. That was X and that was Y. Okay, so if you went along 1 and up 1, X is 1, Y is 1. There'll be a dot there. Now we're going to draw in the X and Y axis various elements. Okay, so sometimes we need to go left more than 0. All right, so I'm going to draw it like this. So now if we've got an antenna that goes from here to here, we will start off at X is, say, -2, -2. Y is, say, -2, and it might go to +2, +2. So there's 4 coordinates, if you like, for each element, which is why there's got all these boxes here. Z is the plane that goes up this way. Okay, so it's a 3-dimensional kind of space we're playing in. So if we wanted a particular dipole to go north-south from here to here, so that I'd want a dipole that long, whatever it is, let's say 5 meters long, right? Y1 would be 5. Actually, we'll do it for 20-meter band, so it'd be 5.2 meters. There'd be no, well, unless you really want to offset it, but if we keep X at 0, then we can do Y2 at -5.2. And now if you look at the view tab, you'll see there's a line which goes north-south. Y is at the top, X is over at the right. Okay. However, it doesn't know about our coax. This is called a source, and there's some codes in here. And what you need to know today is that wire 1, because we've only got the 1 wire, and we want the center of the center of that element, the green element here, to be where we fit the coax. And this is going to assume that our coax, which looks, if you remember, you've got the braid here and you've got the centre pin coming out the middle. That means when we put our source, which is always on a red dot, we hit the view tab, there's the red dot. That means it is assuming that at that point, which is right in the middle of that antenna, we're going to send the centre of the coax one way and the braid the other. It's just called a source, okay? That's all you need to know right now. And then we can calculate it. There's a couple of things here. We've got free space, perfect, and real. I never use free space. I never use perfect. I only use real, and I have a ground set up. The default, it works fine. So don't worry about that for the time being. Now we can add our height, okay? So if we add our height at, 10 meters above the ground, this doesn't seem to make any difference at all, but we'll say copper wire. And that's all we've done. It has brought through, by the way, this here, 14.25, I'll say. Now, if we go over to the calculate button, it's brought 14.25 over. All we can do is type it in there. We hit the start button. We shouldn't get any complaints. It's got a rough SWR impedance. As antenna constructors, we're not too worried or interested about impedance and SWR because we know, as a constructor, if it's a dipole, we can go out in the field and cut the ends and trim it and do all that sort of stuff. And there's our far field plot. So at 10 meters above the ground on a flat top dipole, if this is what they call the azimuth, and this is the elevation angle. So the elevation angle is if you were standing on the sidewalk, the pavement, right, away from the antenna, and you had special RF glasses. Bearing in mind it's a north-south antenna, you could see the RF going. It doesn't stop where that black line is. That's our kind of 0 dB reference point, but it just gives it a good idea. And then we can move that cursor by clicking and hold down to, let's say, 10 degrees off the horizon, and that is telling us that we are 1.7 dBi. I'm not going to go into isotropic dipoles, isotropic antennas. In fact, I've either done one or I've scripted one out. I'll have to remember to do that at some point in time. And then over on the left is taking the maximum gain and showing us what the plot is, which we can change to 10 degrees off the horizon. And if you remember, 10 degrees, it said 1.7, so we should be seeing 1.7 dBi off the side. If you want some kinky stuff, you can hit the 3D far field plot and hit OK, bottom left, and you can get a nice little plot that looks like this. Right, so I will save that. I'll put a directory on our company Mega account of all the models so you'll be able to download them. But to start with, that's all for today. All right, next time we're going to convert this, show you how to cut it into two, and we'll make an inverted V dipole. Then we'll do some verticals, we'll do some elevated verticals, get into loops and do all sorts of things. All right, so it should be quite good fun. And we'll see you on the next one. Okay, enjoy your radio and bye for now.